VLSos here. This is a video lesson on complete transformation of a function. And I'm going to be supplying an example of transforming a trig function. We're going to start with the general equation for a transformation, and that is y minus k divided by a is equal to any function of b times x minus h. The variables in this equation are x and y. F can be any function, sine, cosine, tangent, squaring, cubing, exponential. The other letters in this equation are parameters, and each parameter affects the function in the graph in a different way and performs a different transformation. Many people are used to and comfortable with equations that are solved for y. We can solve this equation for y by multiplying both sides by a and then adding k. And it would look like this. Y is equal to a times any function of b minus times x minus h plus k. These are equivalent equations, but the first one here has the advantage of being consistent when we describe the transformations and knowing which parameter affects which axis. These parameters can be listed and with their effect, A performs a vertical dilation. A affects the vertical axis because it's grouped with y. A can be thought of as multiplying or dividing by y, and depending on the value of A, it's going to either stretch or compress the vertical axis or vertical distances. B is grouped with x, and B affects a horizontal dilation. And of course, depending on the value of b, it's either going to stretch or compress horizontal distances. The parameter h, which is grouped with x, slides the graph left or right, which is a horizontal translation. Translation is a fancy word for slide. K performs a vertical translation, which is a slide up or down. If the parameters that multiply or divide our variables are negative, then they perform an additional transformation, which is a reflection. So we can get a reflection over the y-axis when the parameter that is multiplying or dividing x is negative or less than 0, when b is less than 0. And we will get a reflection over the x-axis when the parameter that affects y is negative. So when a is less than 0. A and b affect both dilations and possibly reflection if they're negative. Two different types of transformation in the same parameter. Let's give an example. We could start with the equation y is equal to 3 times the cosine of pi times x plus 1 minus 2. This is solved for y, the vertical variable. I'm going to change it into the transformation equation before I describe the transformations. I'm going to do that by adding 2 to both sides and then dividing by 3. When I do, I get y plus 2 divided by 3 is equal to the cosine of pi times x plus 1. Now I'm going to describe the transformations so I know how the cosine graph has been transformed so that it's much easier for me to graph. Descriptively, I'm going to think of this 3. The 3 is dividing y, so it's going to affect vertical distances. Division by 3 is counterintuitive. Vertical distances are going to stretch. When we see division, we think diminishing, but dividing by 3 stretches. Descriptively, we could say vertical stretch factor 3 or times 3. Next, I'm going to consider this pi. So pi is multiplying x. Pi is a number approximately 3. And we think when we see multiplication that we're going to expand. But multiplying x is going to perform a compression. Pi is greater than 1, so it's going to compress x by a factor of pi. This is a horizontal compression by a factor of pi. And if we're going to compress by a factor of pi, if we're going to shrink distances, then what we're going to multiply by is 1 over pi to shrink them by that factor of pi. The 1 is being added to x, so it's going to be a horizontal slide. Addition, we think, goes to the right. It's counterintuitive. We're going to slide horizontally to the left by 1. Or we could simply say left 1. The 2 is being added to y, so it's a vertical translation or slide. And we see, when we see addition, we think up, but it's counterintuitive. We're going to go down by 2. This is a description of what's happening to the cosine function. So I can use this description and the graph of cosine to get the graph of the transformed function. So what I'm going to do is I'm going to graph cosine first. Cosine starts at its maximum 1. And if I make each of these boxes 1, then pi is going to be approximately here. And 2 pi, with a value that is about 6 1/4, is going to be about here. And when I graph cosine, it'll start at its maximum. At pi, it'll reach its minimum and complete a period at 2 pi. So cosine with these choices will look approximately like this. When working with the transformation of trig functions, it's very helpful to think of the trig function in 5 important points. The 5 points that I have here are the maximum and minimum value of the sinusoidal wave, 2 intercepts, and then another maximum to show where it completes the period. So I'm going to use these 5 points, and call it a 5-point method, and transform these points with my description of my transformations to see where those points go. And once I have transformed those 5 points, I can fill in the middle with the sinusoidal curve guided by where those 5 points were transformed. I find that the first point, or the easiest point to work with, is the y-intercept. So I'm going to go through the description in moving or transforming this specific location. The first thing I'm going to do is perform a vertical stretch by a factor of 3. That means that I'm going to triple vertical distances. The vertical distance of this point is 1. So when I triple it, it becomes 3, or right here. The next thing I'm going to do is perform a horizontal compression by a factor of pi, which means horizontal distances are going to shrink. Mathematically, what I'm going to do is I'm going to multiply by 1 over pi to perform that shrink. The horizontal distance of this point is 0. So it doesn't dilate horizontally because anything times 0 is 0, which is why working with the intercept first is very helpful. I can ignore any horizontal dilation. Then I finish with going left 1 and down 2. Left 1 and down 2 means that this point was transformed to now be in this new location. And I'll mark it with an X. The next point that I'm going to transform is the point that represents 1 period after the first one that I started with. Where does this point go? Well, we do our dilations first. A vertical stretch means that this vertical distance of 1 is going to be 3 again. But now the horizontal compression of factor pi means that I'm going to multiply this distance by 1 over pi so that it has a new horizontal location. The horizontal distance of this point is 2 pi. If I multiply by 1 over pi, then the pi's will cancel out, leaving 2. So this point is moved to 2. I still have my left 1 and down 2, so I go left 1 and down 2 and put an X where this point ended up after the transformations. Now these 2 points came from the maximum and then 1 period later the maximum again. So my entire transformed wave is going to be in between these 2 new maximums. The next point that I'm going to transform is this here, the minimum at the midline of the cosine wave. And I'm going to go through the descriptions of vertical stretch factor 3. Its vertical distance is now -1, so the new vertical distance is -3. Horizontal compression factor pi means I'm going to multiply the horizontal distance of pi by 1 over pi, which is pi over pi, and that's 1. So the horizontal distance gets shrunk to 1. Then left 1 and down 2. Left 1, down 2. This new distance is, this point got transformed to be here. That means that if these 2 were maximums and this is a minimum, I already have enough to visualize the entire wave, or one iteration of the sinusoidal wave between these 2 points. So I'm going to begin sketching my transformed wave, and it's periodic, so it'll go through the same waveform. And now that I have a good indication of what my transformed wave looks like, I'm going to transform these last 2 points, and they should end up where I predicted them to be when I sketched my wave. So I'm going to transform this point. The vertical stretch has a vertical distance of 0, so it doesn't change. 0 times 3 is still 0. Horizontal compression factor pi, I'm going to multiply this distance, this horizontal distance, by 1 over pi. This horizontal distance is pi over 2. Pi over 2 times 1 over pi, the pi's will cancel out, leaving 1 over 2. So this point moves to have a horizontal distance of 1/2 approximately there. Now it's left 1 and down 2. Left 1 and down 2 is right where I predicted it to be. Let's see if that works out for this last point in the 5-point method. I have a vertical stretch factor 3, has a vertical distance of 0, so it doesn't change. Horizontal compression factor pi, I multiply this location, this horizontal location of 3 pi over 2 by 1 over pi, the pi's cancel out, leaving 3/2. So the new horizontal distance is 3/2, approximately here. And then left 1 and down 2. Left 1, down 2, right where I predicted. These 5 points guide how to draw that sinusoidal wave, which I've already done, and this sinusoidal wave continues in both directions forever. Now, if we're familiar with the properties of waves and the ways that we describe them having a midline and an amplitude and a period, we should be able to observe what those values are and see them in our choices of transformation. This new transformed wave has a midline that I've drawn as a dotted line, which is at -2. The midline is at -2 because the midline at 0 went down by 2, confirms with our description. The amplitude of this wave is the distance between the midline and any of its extrema. We can go from midline to a maximum, and the distance is 3. Midline to this minimum is a distance of 3. That was the same as the vertical stretch of 3, or the amplitude, which is shown out front multiplying the function in this equation form. So that checks as well. The period of this function is the horizontal interval to complete one iteration or one complete period of the wave. The period can be observed as the wave going from maximum to maximum over the space of 2. So we could say the period of this function is equal to 2. And the period is related to the frequency as 2 pi over the frequency, the b value that's used in the transformation. We have a b value of pi. So the period of 2 confirms to be 2 pi over that b value of pi, and this simplifies by the pi's canceling out to leave 2. So the observed period confirms that has the correct value that corresponds with b, the frequency that's used in the equation. Transformations are worth thinking through slowly. It can get confusing quickly. Take your time.